it's important to have the ecosystem of these building blocks, like Lego blocks, and you can put them together without too much thinking about the infrastructure management or not thinking at all about scalability. You don't need to think about some scheduling policy.
Can you explain what the serverless technology is in very simple terms?
More focus on developing the code and less on operational aspects.
What would be the advantages of using Java for serverless, or benefits, or maybe some challenges too?
If you have already your Java developers and the offerings are there, then why you need to reskill? You need to upskill people anyway in the cloud technology, and then now throwing away the programming language can be quite expensive.
When I think about scalability, it's more about like volume, right? But then there's also a performance at the like individual level of function, like you're saying. Are there any considerations for increasing the performance of those functions?
It always starts, it's really, really cheap, and then it becomes more and more expensive.
I'm clueless about this stuff, but now I have better general understanding. Hello, everyone. Welcome to Lyoshin podcast. Today's guest is Vadym Kazulkin. He's the head of development of ip.labs and also an author and speaker and a member of AWS Community Builder Group. And he also co-organized a Java User Group in Bonn, Germany. Welcome, Vadim. Nice to have you here.
Thanks for having me, Vid. Yeah, looking forward to what we will be talking about.
Yeah, sure. So I invited you to talk about serverless technologies and AWS and Java. But before we jump into the topics, can you please tell a little bit about yourself and your journey, how you became, a technology expert, and the work that you do now?
Yeah, thanks. Sure, you introduced quite well what I'm doing. Yeah, so basically, I grew up in Ukraine, in Kiev, where I also studied. Then, in the beginning of the century, I moved to Germany, and I started more or less as a Java developer in the classical data center environment, like building monolithic applications, as probably everybody did 20 years ago. But we had specific needs in our company ip.labs. We are dealing with the software for designing and purchasing of the photo products like photo books, calendars. So basically everywhere where you can print the photos, and this is of course spiky business. Yeah, you have campaigns during the year, but after the summer vacations or in the Christmas season, people are purchasing more and more, and we kind of face some scalability issues that required us. It was back 7-8 years to rethink how we operate our software, and then kind of started my journey to migrate the application to the cloud. It was, maybe we'll be talking about basically first of all lift and shift plus some things that just will help us with the scalability, but later we just more or less jumped into this journey of cloud native services or serverless services. And basically we are trying to be as serverless as possible in our company. Not always possible, but at least that's more or less the first strategy. And of course, Java kind of struggled and still struggling there, and so we also needed to embrace other programming languages to just fully utilize this potential of serverless, like JavaScript, Node.js, all these derivates like TypeScript. But for me, Java always was a passion, and I'm kind of this. I have these two passions: AWS serverless and also Java, and I research, try out ways how Java can be utilized within function as a service environment on AWS. So this is basically kind of the situation. I now currently developing a bit less, but because I have more managerial role, but in order to stay technical and relevant and to be able to speak with people, I I use this opportunity to develop still and write blogs and articles, just also to try out the concepts and not only hearing about something, because the developers, they totally, they can see if somebody just understands what you are talking about or not, and that's why it's just experience helps me, but I need to try things also out by myself. Yeah, that's
Yeah,
basically it.
you need to. Okay, cool. That's what they say, right? You need to walk your talk, so otherwise people think you're just talking and you don't really do anything. So,
Or really don't
yeah, with your
understand
role,
at
it's
least.
maybe hard.
Mm. Yeah.
Right, right. Okay, cool. All right. So, can you explain what the serverless technology is in very simple terms?
So basically, I think it's useful to start with the whole evolution that also led to this,
Sure.
that serverless became popular. So basically, we always saw the race of abstractions dealing with the infrastructure and all the components. So there are so many layers like networking, storage, server, virtualization, operating system, runtime. Then only then comes our application on top of everything else. And of course, the question is, how much time do you deal with all that things besides your application, which is your core logic? And basically the idea is that you would like to write the business logic, and everything else is probably not something that differentiates you. That's why we saw this, that you need to manage everything in the private cloud, but with the public cloud providers like AWS, Azure. I'm only expert in AWS, or uh, we always saw this race of abstraction. Yeah, we had this infrastructure as a service where you just simply can get a new server pay API call, so that the whole virtualization, server, storage, networking is more or less hidden. We had then the race of abstraction with platform as a service, or containers, all that stuff, that even operating service and virtualization and everything else is abstracted away. The idea behind the function as a service is that even if we get the server and networking and storage, then at least then we need to install lots of tools, or we need just to install our programming language. We need to install maybe a web application server and manage it. With function as a service, we basically get this environment, or at least building block for free. If we are talking about function as a service, we get the environment and we deploy our code, and it can be executed. Yeah, the one special thing is that the one environment is only capable of executing one function in a time. Yeah, and then the environment will be returned back. Yeah, and in case of Java, for example, or talking about AWS Lambda, which is function as a service offering for AWS, you will receive kind of managed Java version, and you simply deploy the code there and it will be executed. But of course, it's only weak explanation of what serverless is. It's only function as a service. For me, the biggest power of serverless comes out then you have different serverless offerings. This one function as a service is for executing business logic, but we also need other blocks uh, like managing the API gateway. There the user request comes in, or you need the database. That's also very complex stuff to manage the database, scale database. The whole scaling aspects are very, very crucial. So for me, it, if I'm speaking about serverless, it's important to have the ecosystem of these building blocks, like Lego blocks, and you can put them together without too much thinking about the infrastructure management, or not thinking at all about scalability. Think that it will be scaled instantly. You don't need to think about some scheduling policy, which will be maybe very slow. Then you need more, and then it's not there. So this is more, for me, it's basically about building blocks. There are also very interesting discussion about pay value. Maybe we'll be touching about this. So is it important to pay only if the service is there, and not to pay if it's idle? Like our business is more or less, we don't have too many orders in the night, for example. So why we should pay for the infrastructure? But it's much more different topic about this. But yeah, this is steadily raising of abstractions is what led to the kind of popularity of the serverless technology, but also that the thing that microservice architecture became popular, and then dealing with infrastructure and the microservice application is even more complicated. We have so many servers that need to be scaled out, so this is nearly impossible. That's why this popularity, but of course there are lots of trade-offs. Yeah, it's not that you get something for free, the complexity is shifted somewhere else. Yeah, maybe it will be
Mm-hmm.
one of the questions where, but this we can be talking lately about this. But basically, it's the thing is that you can maybe more focus on developing the code and less on operational aspects.
Okay. So yeah, it's like an invisible layer basically that takes care of a lot of infrastructure things for you, and you as a developer just need to focus on business logic basically, right?
It's an
Writing the
infrastructure update.
application code and
Mhm. Yeah.
yeah, and using those blocks like you said, that takes care of underneath of application, whatever is need to support it, like skeleton or backbone or whatever we can say. Okay.
Yeah.
So how does AWS specifically support serverless? Are there any special special unique things that they help with? Why do you stick with AWS?
So I personally think that all major cloud providers have offerings that they are quite similar. Yeah, they have different names. What is
Mm,
Lambda kind of function as a service? It will be on Azure functions, on Google functions. So basically many many cloud providers offer basically the same. You have managed API gateway, you have managed function as a service to deploy the function in the specific programming language like Java, Python, with some recent version. You also have managed databases that can be um, relational databases. It can be also NoSQL databases, like in case of AWS's DynamoDB, their own offerings. You will always have some fully managed notification service, some fully managed queue. This is basically the things are where they are. For us, it was basically the decision based on we are based in Europe, and AWS had their kind of data centers or the really regions basically here, and so
mhm,
that's why we had then back then 7-8 years a feeling that we will be quite supported there, and uh, also that was kind of that decision. It's but basically all cloud providers are very close. There can be some unique things.
yeah.
Basically Microsoft have unique things towards Office and Microsoft offering, and now probably something like managed
Mm,
OpenAI services because they heavily invested in OpenAI, so like conversational programming. So I expect the things coming from there, but also AWS has now Code Whisperer. So they are basically many cloud providers trying to do the more or less the same in that area.
I see. So it
Mm.
was just a convenience for you. Amazon was there kind of first, and they had good support and infrastructure in Europe. And okay, that makes sense. Well, yeah, that's how you win markets, right? You jump in first. That's great.
Yep.
Um, then, so let's talk about choice of Java for serverless, and why would somebody choose Java?
So this is probably a very difficult question. Basically, you are seldomly you have nothing and you are thinking how to select programming language. Basically, if you start the company, it's a different story. I see a lot of advantages to have some technology which supports back end and front end at the same time, like Node.js and all that stuff. But of course, sometimes you have already your code, you have your expertise in the
Mm,
company, and if you're just the company writing which writes the business logic in Java, or you have Spring framework for the full-fledged web development. And now your challenge is how to get into the cloud, and you would like to reuse as much as possible, at least, or try to think about reusing the code, then of course you would like and you will prefer to stay with Java. Yeah, this is basically how I think it's
Mm-hmm.
really cool community, a lot of really powerful open source project out there. Probably I'm too much in that community, and I don't see something similar with other programming languages. There are always some open source frameworks, but there is plenty of choice in the Java space. And of course, I, I think that the biggest investment that the company do anyway is into knowledge. Yeah, and if you have already your Java developers and the offerings are there, then why you need to reskill? You need to upskill people anyway in the cloud technology, and then now throwing away the programming language can be quite expensive. Um, so this is
I
kind of
see.
my thought. But of
Yeah.
course, if you just probably will start small company, then I could imagine that you will stick to something like JavaScript, Node.js, and all that stuff.
Okay, so so that just in your case happened that you already had experts in Java and also build your older version in Java, and you just, like you said, you just lifting and shifting, and it was easier to stick with it. But otherwise, people could use something else. Cool.
Yeah, that's it. But as we
Are there?
started to explore
Mhm.
serverless, that was quite different because we faced some challenges with adopting Java on Lambda, like function as a service. So that was the situation that we really needed another programming language back then, 5, 6 years ago. Yes, for writing monolithic application, for lifting and shifting application, we stay with Java. We have still plenty of Java code, but back then it was at least for the public facing application, Java had its unique challenges with AWS Lambda. So we needed also to look for other solutions. But now, since 2 or 3 years, there are offerings which will support. Yeah, so the companies who are now thinking about the migration, they are, I would say, in the better place to leave Java, to stay with Java completely.
Mm-hmm. Okay. So let's talk about then what would be the advantages of using Java for serverless, or benefits, or maybe some challenges too from the other side.
So the benefits, I basically explained them. This is the community, a lot of open source projects. So you basically
Mm-hmm.
using all these frameworks, they lead just to for increasing the developer productivity. But of course, especially with the serverless, there are these unique challenges that basically with the function as a service, you have short-lived environments. So the function is executed and then coming back. The environment is then kind of returned for the new function. But it's quite expensive in case to create this environment. Yeah, because this is environment you need some service that more or less starts the environment, then the Java virtual machine needs to be started, then the code needs to be downloaded and deployed. And this is what is called cold start in serverless application. It's not specific to Java, but Java is designed as a language for more long-lived applications, like the application living in the web application server. It takes maybe several seconds to start, but then the application lives maybe for weeks. Yeah, so you are ready to pay. But with
Mm-hmm.
the short-lived functions, to pay the price of 3 to 5 seconds, it leads that there is kind of delay in the response in case the new environment will be created. That's important thing. If there are enough environments to serve your request, you don't have the problem. But in case you deploy, for example, the new function, then the environment needs to be created for this. It's new code, it needs to be downloaded and executed. Another situation, if you have, for example, 5 requirements, but 6 requests now are coming, then one environment is missing. It needs to be created by the cloud provider. And all this cold start thing is especially with Java as a programming language, but the same will be with C# and other languages. It's quite significant. So just one of the topic that I investigate, and at least as there have not been any solutions to that, this cold start, which may happen in 1% of the cases, plus minus, it's just 3 to 5 seconds, which adds to the execution of the
Mm-hmm.
function of the business logic itself. And this is something where there are studies that if the user waits for the response for more than 1 or 2 seconds, then the user may drop. Yeah, and this is this cold start problem, especially with Java and so on. It led to the situation, especially if it's a public facing application, that it led to the problem. If you have some kind of the asynchronous processing, it just doesn't hit you. Then in 1% of the cases, you will pay several seconds for the cold start. It's not a problem. But for the public facing
Mm-hmm.
applications, and there are many, if you need to register yourself or to log in, this is synchronous public. This is synchronous invocation. Yeah, you cannot process without
Mm-hmm.
being sure that the user was successfully logged in, has sufficient rights, and all that stuff. The same maybe is for ordering, at least partially. So this is where
Mm-hmm.
Java at least struggled from the beginning. It's um, it's one of the reasons why people sometimes abandon to use Java, and even more if they use these frameworks like Spring, because in their initial form, because they use dependency injection, annotation processes, or things happening during the start time of the application, which then increases the cold start. So it was kind of the situation that all the paradigm, how we developed application, like for long living applications, all this framework, were not sufficient in the serverless world, or they just, you need to turn this upside down. You need
Mm-hmm.
very quick start. Yeah, all this caching behavior, all that stuff, all this garbage collection, all these things that are very that's natural and normal in the long living environment, but it costs you processor time. It's costs all the stuff for the short living Lambda function. It was kind of not beneficial at all. So that's why kind of
Mm-hmm.
uh, different approach was needed, how to deal with all that stuff. And currently now there are these approaches, and that makes me optimistic that Java will now be even more popular in the serverless
Mm-hmm.
world.
I see. Okay, that's great.
Mhm.
So let's. So you mentioned a little bit about the need for scalability for your application, and that's kind of one of the reasons you went to serverless. How does serverless computing help with scalability of applications?
So this is one of the properties of the serverless, that is instant scaling. So that will be scaled automatically. Yeah, the API gateway scales for you, or there are so many requests per second available. The same is with this function as a service. You can scale up to X environments in parallel instantly. The same is also for
Mm-hmm.
databases, queues, and so on. But of course, nothing is kind of infinite. Yeah, you cannot scale for free, or also the cloud provider needs to plan the capacity and all this stuff. That's why it's very important. So every service, it's not only AWS, but every service in each cloud provider has its limits. They call it, AWS calls it quotas. And so you need to understand how,
Mm-hmm.
in case of its Lambda function as a service, how many instant environments can you have? For example, the default one value is in our region in Frankfurt, 1,000 per account per region. So basically, instantly you can only have 1,000 functions executing in parallel, and you need to see, can you increase this limit? This limit is increasable, but there are limits that are not increasable. For example, you have so many you can start right away from 1,000 functions, then you can scale up to 10,000, for example, per account, but with certain steps per second. Yeah, and sometimes you can increase, sometimes you can't increase. So you need it, just before you use some service, you need to go to the quotas or documentation where these quotas are listed, just to understand the scaling behavior. Yeah, and think of, is it enough for my use case, or not? And then, of course, is the scaling behavior adjustable? Then you can send the request to AWS, and in that case, describe your use case, and maybe they will adjust it for you. But it's kind of I think it's a big misconception of the cloud itself. It just doesn't matter serverless or not that everything scales infinitely, but it's not. Yeah, otherwise it's simply a huge burden to the cloud providers. So they need to plan the capacity just to build the right size of the data center or data centers. So everything has its limits, and it's important just to think a bit in advance. Probably if you start a new application, you won't have millions of users, but you need to check where you are, how the services are scaling. Sometimes you have alternatives that are better scalable, but they are more expensive. You don't want to start with them. But basically, this at least as long as you understand that. And this is one of I initially spoke about that the idea behind serverless is to more focus on the business logic. Nevertheless, it shifts this complexity of that developers need to think about scalability properties of all these services anyway. So it's not that you just do something and it will magically work for all scenarios. No, we need so the good engineering knowledge is still required in thinking, architectural thinking, how just maybe to turn something from synchronous to asynchronous processing with a queue in between, something like this. So this still remains. Yeah, this complexity still remains. So the scalability is there. Yeah, but you need to understand how scalable is each service that you use.
Yeah. Okay, I see. So when I think about scalability, it's more about like volume, right? But then there's also a performance at the like individual level of function, like you're saying. Are there any like considerations for increasing the performance of those functions, if you will? Just maybe from your experience. I know there may be some, a lot of cases how you can do it, but maybe from your case.
Oh, that's really difficult question. Just thinking about how to answer that, because the functions itself they are kind of independent. But of course, you can use the common layer like the database and all that stuff anyway. Um, so basically, you need to think what you can cache, what you can't cache. So there are also caching services in between. So all that stuff that's I think relevant in normal world. Where you don't do serverless is
Yeah,
also relevant here. So you can cache on different levels. You can cache on API gateway level, just then the request is coming. In case you are requesting something statical and nothing is changing, you can kind of uh, cache it on the CDN level or something like this. You can cache on the function level. You can cache the results from the database queries in the function itself, just not asking the database if you are quite sure that this can be at least cached for a certain period of time, and then invalidate the cache. So this is basically the normal engineering best practices are also valid here. Um,
okay,
but of course, you need to think if you, for example, take the function you you resolve the function with a certain amount of memory. So you need to think just okay, too much caching can also consume memory. So but this is the same as also in the server environment. You just cannot cache endless.
I see.
uh,
Yeah, so same consideration sense for normal application or whatever, all day application or whatever it's called, right?
yeah.
Yeah. Okay, I see. Um, so let's talk about cost. What is the impact of running serverless infrastructure on the cost of the application?
So basically, of course, you need to understand as you need to understand the quotas or limitations of all services. You need to understand the pricing model of all services. Yeah, this is something like API gateway will charge you probably per request. You need to understand how much one request costs, and there is of course some package deals starting from 1 million requests. It can be cheaper. The same is also basically on the database side and also on the function as a service side, where you basically, in case of Lambda, you are paying for number of Lambda invocations. That's one factor, and another factor is a gigabyte per second. So memory execution. Yeah, if you have half of the gigabyte, then you pay the half of this. So this is basically the trade-off. So maybe I can precise. You asked about the performance. Uh, there is one thing that is different. For example, in case of function as a service Lambda, the only one parameter that you select is the memory. You don't select the CPU cycle. You will get it proportional. And this is kind of cost performance factor that comes together. You need to figure out what will happen if I will double, for example, the memory. If I will get function executed in the half of the time, then I pay the same, but the response returns quickly. So there are tools that you can test, especially for function as a service, what's the best price performance trade-off. Yeah, how much memory I should give and how quickly I will return response. But basically, these are both factors of the price. In this case for Lambda, yeah, and this is then you need to run multiple tests to figure out what's the best trade-off. But basically, of course, especially with the serverless technologies, there is a risk that you don't control your pricing, because the more requests, the more you will pay, and there is no. Basically, you can of course apply alarms that you will be alarmed in case that the cost will go up unexpectedly, and of course you can have DDoS attack, and then all services will then process more requests, and the price can become unbounded. And I think that at least really many are not very comfortable with that situation, because that you have a feeling it's out of your control. Yeah, and this is especially true, and I hear and I also see that serverless at scale can become expensive. Yeah, if you are in the startup having not too many users, you will probably don't see nothing in the bill. So our first application, serverless application, to create products, photo products, manage photo products, it cost us several dollars per month. You don't even notice because there are not too many users creating them. That's not real users. That are basically support users or our partners creating that, but not the real traffic. Yeah, so this is something where I think this is one of the things that you need to understand the cost. So developers also need to understand the cost. They need to understand the pricing of these services and the scalability of the services. It's quite interesting how many things the developer would need to understand with serverless, because basically you don't have any system administrators there. Yeah, you have team developing in total, as the whole team need to understand and deal with all that concepts. But basically, the most expensive thing from my experience is the observability tools, monitoring observability tools in the serverless space. They are really quite expensive. Sometimes even the observability kind of tracing that you can deal with errors and see, because in the serverless world you have so many teeny pieces, one service calling the others, and in case you have a problem, you would like to have the whole trace and understand where it is. But these services are uh, really expensive. Sometimes you pay more for observability as for the whole rest of the serverless services together. Yeah, this is I think it's true for all microservices currently, that this is very complex thing to trace this invocation between serverless, and then you need to think about maybe only analyzing, like pushing these metrics only for not for all requests, but for example 10% of requests. But then you risk, in case something is occasionally happens, that exactly your request isn't there. That's also then the trade-off. Yeah, how much would you want to spend? How much risk would you like to take with that? Because this is sometimes at higher scale, it may become a problem. And I see that the people are really asking cloud providers, also AWS, can you provide kind of enterprise level pricing for serverless, meaning on the high scale, maybe some price reduction. because it always starts, it's really, really cheap, and then it becomes more and more expensive. And then it's a big trade-off. So also what is important with serverless, you need to think what you are not doing. It's not only infrastructure, it's also upgrades and all the security things like that comes with the you upgrade, you patch, all the security stuff. And of course, it's immense value if you don't spend time with that. Yeah, and the cloud provider or managed service provider is doing that for you, but it has its price in the end. Yeah, so there are companies saying it's too expensive, and then you're asking, are you doing this, and this by yourself? And then you hear, yeah, we are not paying attention to security anyway, and then they don't appreciate that somebody is taking care for you. Yeah, this is something that you
Yeah.
need to understand the whole benefit of the stuff. What does it mean, the managed service? What's the work to be done on your behalf? Yeah, and then it sometimes may be relative. Yeah, but I mean, and then of course you will have the highest pricing, but you offload so many things that you need then to compare. It's called total cost of ownership. Yeah, if I now have more time to do something else to produce value, maybe it's worth paying the price to the cloud provider and having time on the developer's shoulder to produce something new, quick, and all that stuff. And this is maybe one of the things that I see most the benefit of serverless, or at least with one star, that you are many things you are capable to do within the team itself. Yeah, you don't have some team of the system administrators that you need to ask to release, and then they have their own priorities. You can deliver the software from ground up to the production within the team. And this is, of course, that increases speed or time to production. There is a star because the complexity comes with the serverless application. They are heavily distributed systems. And this brings ton of technical complexity that developers need to deal with, and they need to be skilled in design of distributed system. This is the skill that comes from the experience. You cannot start with it. You need to experience the things that
Sure.
small things are breaking and the rest of application is working. So this is something that we had to deal with because our first application, so as we started migration, it was basically monolithic. Yeah, and then you don't have these teeny pieces, and it was easier to operate. At least we thought it was. But this is kind of this trade-off, price, performance, understanding, and all that stuff. But from my personal experience, I see that the serverless, or at least thinking about these aspects, made engineers better engineers. Yeah, because that was our biggest problem in the data centers. Developers didn't understand operations at all. There were some servers, some storage, and they had unlimited capabilities, as we thought, because we didn't know these capabilities. We simply did something, it should run, but it wasn't in some situation. It didn't run. Yeah, and now with that, we need to
Yeah.
pay attention because we know the things will go wrong and how to deal with that. It's just another stuff. You need to upskill people. But generally, I personally see that the developers are quite happy to deal with that things. Yeah, because they're constantly learning, and this is
Yeah.
one of the motivations for them.
So in contrast, when you don't have serverless, you have to deal with cost for data center or your own server somewhere, right? You also probably have to hire people to maintain all the systems, upgrades and licenses and all that stuff. So if you calculate all that cost and what you pay for serverless, at the end of the day, serverless may be the same or even less, maybe a little bit more, but you get also better performance, hopefully, or like you said, you free up some time from your team members to do some other stuff. So you really have to, as a manager of technologies or whatever, like CTO, CIO, whatever the role is, they really have to compare and contrast this and make the decision for the business. But there
This
are
is
also benefits, like you mentioned, about scalability, for example, right? You can ramp up services really quick, really fast. If you have your own data center, you may be limited there. I remember a long time ago, I started with the company. It was a small startup, and we actually had to, I don't think even cloud really existed back then, or maybe it existed, but wasn't so popular. So we were building our own racks in data center, and we literally had like dozens of servers laying around on tables, and our sysadmins were installing software, doing some configuration on each, and it was taking like, a few days for each server. And then driving them on tracks to the data center, installing everything. That was a crazy, crazy project. I remember they were dealing with this. But now it's like push a few buttons and you have a bunch of servers sitting in the cloud for you, ready for you to work. That's cool.
Yeah, this is what you
Yeah.
first mentioned. It's the total cost of ownership. You need to compare things. Serverless makes cost transparent. You see them. You see what each service costs you in the end, and even what each function as a service Lambda function costs you. And then you can think of the optimization. So cost optimization can become one of the tasks like performance optimization. If you see the potential, because it's not something is not efficient, you can prioritize this. It's visible. Yeah, this is one of really benefits. And yeah, what you are telling now, so what I observe and people observe with serverless, at least if you are just a bit familiar how to deploy, you need to write infrastructure as a code to deploy it. But basically, sometimes we had an idea what to try out, and yeah, literally 1 hour later, we deployed the code. We don't need to ask somebody for permissions with serverless. We simply write them. We are skilled how to write this infrastructure as a code, just to deploy it that an automated way. And we can simply test and validate the idea. Of course, you can do mostly the same also with managed containers. Yeah, as long as you are not managing containers by yourself, the scaling behavior, you can basically do the things also there, but you maybe have to take care how to build Docker image and all that stuff, CI/CD on that. So we're simply deploying only code. So at least for trying new things out, and especially important for the startups or the companies working the startup way, that you simply try to validate idea, not to think and overthink. That's really cool. But I also see now a lots of enterprises dealing with serverless, like Lego and many companies doing even a PostNL from Netherlands, the huge post company processing millions of parcels. They are going completely serverless because in this world of competition, the speed matters. And sometimes you value speed and go to market. That's the same more than maybe the costs. Yeah, in that, but you need to understand, think about costs. You need to make them visible and work on that. Yeah, just CFOs and all the kind of people, they are not feeling comfortable if you cannot tell them how much the thing will cost. Yeah, they will chase you. Anyway, and it's understandable. It's their money, it's the company's money. You cannot say, yeah, but I'm quick, but I don't know, $10 or 5 million. I don't know. It's not the answer. You need to approximate at least. Yeah, but then they need to give you business requirements for how many users do they expect. And otherwise, you can't answer the question. So this is kind of going in both directions.
Like chicken and egg, right? They don't give you business requirements. They don't know themselves. And they expect you to estimate the costs. That's the challenge always between dev and business. Even like estimating simple tasks, but estimating cost of serverless environment, it's even more complicated. Yeah, that's funny that you mentioned it. It's actually the real challenge today.
But you can start with something. I mean, you can say, okay, I can approximate for 100 users. Yeah. And if they say, okay, well, for 100, it's cheap, but for 2 millions, it's expensive. Then we can say, okay, if we have 2 millions of users, then we have success. Yeah. Then we will earn enough money to think about optimization. But now the speed matters. Let's get this 100 or 1,000 users, and then we will be talking.
Yeah, exactly. You start small, you build up, and then you earn more money, and you can afford it, and you pay for it. Okay, cool. So let's touch on security a little bit. You kind of mentioned it already, but how does AWS specifically or serverless in general ensure security or help manage security concerns for the applications?
So for me, with serverless, as so many layers are managed, then for all managed layer, the cloud provider, in that case AWS, is responsible also for the security. And that's a cool thing because there are so many things in between. But what remains is the security of the application itself. Yeah, that's a responsibility of the developers and will always be. Yeah, this is nothing that somebody can help you. You have a lot of other tools just to check for static dynamic vulnerabilities, package management, especially in the Java world. You have so many open source projects as dependencies that you don't control. People can release security vulnerability and you simply update the version and you have it. So you need this tool. Yeah, so the application security remains on your shoulders. And everything else, and I think it's more than 90%, is on the cloud provider. They ensure that the servers have the newest version of operating system, and if there is some known vulnerability, it's on behalf of them just to fix it and roll out the fix, even that you even don't notice that. Yeah, the same is also true, for example, serverless with Java. We don't even know we know the version of the Java runtime, but we don't know the minor version. Yeah, it's now Java 21, but is that 21.03? We don't even know. But we need to be sure that in case some vulnerability will be reported in this Java, then the cloud provider, so the Oracle will fix it, and then the cloud provider will run then the fixed version on behalf. Yeah, so that I don't need to take care. I can't even change something, but I need to have trust that that it will happen. But I have trust because I know that for AWS the vulnerability, that security is priority number one. We also had very huge security uh, uh, finding 2.5 years ago with Log4j, and we saw the reaction of the community. So also AWS relied heavily on that version with security with that vulnerability, and they within 2 days they roll out the fix overall over the world. Yeah, so this is something that's I really appreciate that things. Yeah, and on behalf of that, cloud providers also release the tooling that help you even with application. For example, Lambda function, there is AWS Inspector as only one of them. There are so many tools in the security. They constantly check the deployed Lambda functions if there are vulnerabilities. Yeah, so even in the deployed version, we can check it on our side during the development, during the building phase, but they can help you also if in case it's deployed, that they also look from this, because otherwise the people just kind of checking for vulnerabilities, the hackers can discover it also from this side. So basically it's the shared model of the security, but I see huge benefit also offloading this complex stuff to the cloud provider.
I see. Okay. Yeah, that's cool. I was kind of expecting that they would take care of most or many security things and monitoring stuff like that, and maybe testing something. So yeah, that's great. Okay. Coming to an end. So what would be your advice to somebody who's curious about this, interested in these technologies? How they can learn more, how they can stay updated on this? Are there any resources they can go to and check more?
So basically, we talked about the problems or challenges with Java and serverless. We didn't talk too much about the solutions, but maybe you can find. I can give you with a lot of blog posts or the whole series I'm writing or was writing about how to solve that. There is snap start that helps you with the cold start of Java function. There is also GraalVM native image, which basically is for the ahead of time compilation, which helps you with that. So this is the one topic, just how to improve things for Java and serverless specifically. But basically, if you would like to learn now, there are so many resources out there on YouTube and so on. So plenty of things. But generally, I can advise if you are in the AWS space, attend AWS Community Days, meetups. There are so many around your corner for sure. So many. There are also serverless days. At least several of them happening around the world. So if you just want to start with something, plenty of things, especially AWS, they have so many documentations. They have so many teams with so-called developer advocates that advocate for specific services. Yeah, you can reach to them out. They are on Twitter, they are everywhere. They can give you resources or recommendation about some specific service and all that stuff.
Mm-hmm.
If you can't find that or quasi on your own. So now it's plenty of information. I think cloud is since 15 years out there, and I think since 5 or 10 years, it's more or less, it becomes more and more common knowledge. Yeah, now I'm
Mm-hmm.
more see companies asking. So it's now more. I think many companies simply start now within the cloud because it's easier. Yeah? It's this not the unique thing as it was 7, 8 years ago that there were some pioneers. It's just as with electricity.
Mm-hmm.
It's just it becomes generic. Yeah, and this knowledge also becomes generic. But yeah. So I expect maybe in 5 to 10 years there will be more engineers familiar with the cloud that they don't even know and understand the problems of the private data centers, and will look into the people
Mm-hmm.
who experience that like, okay, you're a poor guy, you had the
The
time, but
dinosaurs.
I don't have this luggage of things that I will not be using anymore. But it's always the space, the pace of how things change is now so big that I
Mm-hmm.
think everybody in our industry is probably working different each 3 to 5 years or need to adjust. Yeah, my mom was also programming, but she programmed 10 years with the same programming language, basically the same. It's now nearly impossible to have this kind of stability.
Mm-hmm.
That probably nobody wants this kind of stability. AI is coming, all that stuff is around, somehow impacting us. So the pace of
Yeah.
change is now really incredible, which makes also the
Yeah.
thing also exciting. Mm.
Yeah, it does, for sure. Hopefully, it will simplify life for developers as well. I know it's coming to the product world and business world as well to, optimize, to provide some tools and services to help people make decisions, to analyze things, or maybe not really analyze, but anyways. And for developers as well, there are copilots, there are automated testing tools. There are all sorts of analyzers or whatever. So I hope it will become easier and easier, and developers can really focus on the hard problems to solve versus just configurations and writing like repeated things or whatever. So yeah, that's cool. All right. Thank you very much for your time today. I think it was great. I asked a lot of lamers questions. Just because I'm clueless about this stuff, but now I have better general understanding and look more into this topic. This is interesting. Thank you
Yeah,
very much for your time.
thanks, Sweet, for having me.